Finally, here at the end of Chapter 6, we get to special products. And special products only happen when we have two things to think about here in Algebra 1. First of all, when we square a binomial, the product is a perfect square trinomial. A perfect square trinomial, and I'll usually call them a PST, or PST for short. So when we square a binomial, remember a binomial is a two-term expression, so that's what we have here. So we're going to square this binomial x minus 5 squared. Now it doesn't just mean x squared and 5 squared, because it's not just x and 5, it's the quantity x minus 5 that's getting squared. So what it really means is x minus 5 times x minus 5. So you need to write it twice and then use the distributive property like we learned in previous videos. So first the x gets distributed. X times x is x squared. X times negative 5 is negative 5x. And then the negative 5 will be distributed. So that will be another negative 5x, and then negative 5 times negative 5 is plus 25. Yes, we do have like terms in the middle, and those middle terms basically double, and we get x squared minus 10x plus 25. And that is a perfect square trinomial. So when we square a binomial, the product is a perfect square trinomial. Let's do it again here on the bottom with 3x plus 4. The quantity, all of it, being squared. So 3x plus 4 times 3x plus 4. So once again, do the double distribution. Distribute the 3x. 3x times 3x is 9x squared. 3x times 4 plus 12x. Then distribute the 4. 4 times 3x is your second 12x. This middle term always doubles. 4 times 4 is 16. Once again, combine those like terms. 9x squared plus 24x plus 16. Note on both of our perfect square trinomials some characteristics. There's a perfect square on the front end and a positive perfect square on the back. Perfect square on the front and a positive perfect square on the back. The middle term is always going to be even because it's always going to be double of what we see in the middle. So those are some characteristics of perfect square trinomials. Let's do them again one more time. These are a little more challenging because they have some different variables and exponents. But once again, the binomial is being squared. So 5x squared plus 3y times 5x squared plus 3y. Distribute the 5x squared to both terms in the second binomial. 5x squared times 5x squared is 25x to the fourth. 5x squared times 3y plus 15x squared y. Now we'll distribute the 3y. 3y times 5x squared is a second 15x squared y. That middle term always repeats itself. 3y times 3y is 9y squared. We do have like terms in the middle, which we will combine. And remember, when we are adding or subtracting, the exponents do not change. The exponent only changed when we multiplied. So positive perfect square on the front, 15 plus 15, 30x squared y, plus a positive perfect square on the end, 9y squared. Let's do it again with the last example here. Negative 10ab plus c times negative 10ab plus c. We'll be using the distributive property. Distribute the first term to both terms in the second set of parentheses. Negative 10 times negative 10 is 100. A times A is A squared. B times B is B squared. Negative 10ab times positive c will be negative 10abc. So the first term is distributed. Now we'll distribute the c. C times negative 10abc is another negative 10abc. Remember, those middle terms always repeat. A positive c times a positive c is a plus c squared. We have like terms in the middle as we anticipate. So the first term is a positive perfect square. Negative 10 and negative 10 give us negative 20abc plus c squared. Positive perfect square on the front, positive perfect square on the back, and an even double of those two numbers. Now, for our other special products, something a little bit different. So let's do number 1 and let's check out what happens when we multiply x minus 7 times x plus 7. So do note that these are exactly the same terms in exactly the same order. One's a difference and one's a sum. Now, when we use the distributive property, distributing the x, x times x is x squared, x times positive 7 plus 7x. Now take the negative 7 through. Negative 7 times x is negative 7x. Negative 7 times positive 7 is negative 49. This time, the middle terms do not double, but they are opposites. So, middle terms are opposites. And if middle terms are opposites, that means that the middle terms are going to cancel when we multiply. So the middle terms are going to cancel here. A positive 7 and a negative 7 cancel, and we get x squared minus 49. So this special product gives us something different. Instead of a perfect square trinomial, now we have the difference, and a difference is what we get when we subtract. The difference of two squares. And the difference of two squares, which I'm going to refer to as the DOTS. The DOTS. Difference of two squares. We're going to see it again in number 2. So once again, notice these are the same terms in the same order. One is a difference and one is a sum. And when we multiply, distributing to 3x, 3x times 3x is 9x squared. 3x times a positive 8 is plus 24x. Now distribute the negative 8 through. Negative 8 times 3x, negative 24x. Negative 8 times positive 8, negative 64. Once again, the middle terms are opposites. And when the middle terms are opposites, that means those middle terms are going to cancel away. And we will be left with 9x squared minus 64, the difference of two squares. 9x squared is a perfect square, 64 is a perfect square, and because we're subtracting, it makes it a difference. Now, these two factors, they do have a special name. And the name of the types of factors that give us the difference of two squares, they are called conjugate factors. C-O-N-J-U-G-A-T-E. Those are conjugate factors. Conjugate factors are just what we see here. The same terms in the same order. One's a sum, one's a difference. It doesn't matter if the minus comes first or the plus comes first as long as the signs alternate. These are conjugate factors. And when we multiply conjugate factors together, the middle terms are going to cancel every single time. So let's see it again on this last one. 5x times 5x is 25x squared. 5x times negative 7 is negative 35x. 7 times 5x plus 35x. 7 times negative 7 is negative 49. Once again, the middle terms are opposites. They are going to cancel, and we get 25x squared minus 49, which again is the difference of two squares. How do we get the difference of squares? We multiply conjugate factors together.